I teach my students how the reading brain works. And first, I introduce the book, Your Fantastic Elastic Brain, to help my students understand the different parts of the brain. And then we went a little further to have my students talk about the functions of the brain, and for them to have a hands-on experience, just looking at the cerebellum, the amygdala, knowing that this is the part that has to do with the feelings, in the cerebellum with emotions. And my students were able to identify the letter box, knowing that this is where their letters that they know are stored. My students have been learning about the reading brain, and now my students are able to explain and discuss how reading occurs in the brain. Once my students know the reading brain, they know that it's not innate. It lowers their anxiety and frustration level because they come to a word that they cannot read or spell yet. They know that reading is just a process, right? It's just because the words that they see that they cannot read or spell yet, it's because they haven't been explicitly taught how to do that yet.
All right, Jackson, tell us what you know about the reading brain.
You come over here.
There's a letter box in Vision Village in the back of your brain. Then once you know the letters, they go to Sound City, and once you know the sounds, you put them together. After you get to meaning mountain, like B says B, A says A, and T says T. And then you can put them together and it says bat. But you need to think about what kind of bat, like the bat that lives in the cave, or the baseball bat, or the bat like you're shooing something away.
Today I'm going to talk about the reading brain. Understanding the reading brain is important for many reasons. It's important for teachers so you understand the instructional components of your lesson and why you're doing what you're doing within a lesson and how you're building the brain of your students by doing those pieces of the lesson. And it's important for students to understand how reading occurs in the brain because it demystifies the learning process for them. There are many instances where students feel that they are not intelligent, or they just can't keep up, or they're different, or whatever story it is that they're making up in their head, because they don't understand that the brain is a muscle that changes and is built over time, and that it takes effort and direct instruction. And so if they're not getting the instruction that they need to build these pieces of the brain, they begin to make up a story for why they're falling behind. And that story usually is, it's because I'm stupid and I can't do this. So it's very important that we have a way to talk about it, how reading is occurring with students. So this image is a collection of information that I have learned from 3 people. Those 3 people are Carolyn Strom, Stanelise Dehan, and Nancy Young. And so I'm just going to walk through this reading brain. And the first thing I want to do is explain how the brain is actually different when we are born versus when we learn how to read, that the structure of the systems in the brain actually change when we learn how to read. So our brain is not the same brain that we are born with once we are taught the language system of reading, the writing system. So we have here spoken language systems that we're born with, and I put that in black, and you'll see sound and meaning. These 2 systems of the brain are in black. Those are the spoken language systems. In white, we have the vision system, because that is not a spoken language system. So I put it in white. When we are born, we do not have a letter box, we do not have a phonological root, and we do not have a lexical root. These are the pieces that are built over time as we learn how to read. What exists in this space of the brain, this is the bottom left hemisphere in the visual system of the brain. What exists before the letter box is actually the spatial recognition system. And what this allows you to do is to see an object in space and recognize it no matter how it appears. So this is why you can see a snake hanging from a tree, a snake on the ground, a snake coiled up or straight, and recognize that it is a snake because your spatial recognition is doing that work for you. Now, when you start to learn letters, there's a battle that occurs between the letters trying to come in and form the letter box and the spatial recognition. There's not enough room in this part of the brain. And so what ends up happening, the end result, once you are proficient in learning letters and your letter box is strongly built, is the spatial recognition part of the brain pushes out and is pushed out, and it is located in the right hemisphere. So what happens while this letter box is developing is you will see students who are flipping letters and mirroring them. So what that means is they will start to write in such a way like this. Like the letter N might be formed like this. It might be mirrored instead of being the correct formation. B might be written as a D, and vice versa, and P's and Q's are often flipped. Now, the reason why these letters are so often flipped for students is because of the spatial recognition part of the brain that is still there and is battling with the letter box. It's the job of the spatial recognition portion of your brain to say, hey, these look the same. There's a tall part here. There's a stick and a bubble. There's a stick and a bubble. What do you mean these are different? That's what your brain's saying is, no, those are the same. Remember, there's a snake. It's hanging from the tree or it's coiled on the ground. Like these are the same things. What's happening? And if you look at the P and the Q, it's the same thing going on where we have this long stick and we have a bubble. And so your brain's doing exactly what it's supposed to do. And it's flagging for you that these are the same. Now, once students master these letters and the letter box is solidly built, this confusion goes away and doesn't happen anymore. So what we have next, with the letter box, is we start attaching letters to sounds, and this is the phonological root. Phonics is simply the connection of letters to sounds. So we have two pathways of this root. We can go from vision to sound, and that's reading. So that's when we see letters, B, A, T, and then we travel up the phonological root to sound, and we say B says B, A says A, T says T, and that is reading. The spelling root, the spelling side of the phonological root is when you begin in the sound system and you travel over to the vision system. And so we start with sound, B, at, and then we have to go over to the vision center and think, what spells B? What spells A? What spells T? And so you see it's the same root. We're just traveling on it differently, starting in one system and traveling to the other. Now, I depicted this route with different vehicles or transportation systems on it. I put a plane, I put cars, and I put bicycles. And the reason I did this is because this ties into Nancy Young's work. She focuses on how 5 to 10% of people seems very effortless when they're learning how to read. For about 75 to 80% of people, we need instruction in order to learn how to read. We don't learn as fast as this top tier here, but it's still not as difficult for this group as it is for the 10 to 15% down below here. And for them, these are people who have language-based differences. It requires intense instruction and frequent repetition in order for them to learn. And so what I did was I tried to show this visually. There's often a misunderstanding that, brains are different in the sense that we don't learn the same way. It's not that there's anything really different going on. You still have to have the letter box formed and form your phonological root. You just, for some people, they need intense instruction and lots of repetition. And so for those people, I imagine, when they're on the route, they're on bikes, they're working really, really hard. For the 75 to 80% of us, we're in the cars. We're still getting there on the route. We're just a little faster than the people on the bikes. And for that top tier, that 5 to 10% that it seems effortless for them, those are the folks who are on this route in a plane where they just get there super fast. So I liked that image to show Nancy Young, to show that we're all on the same route, but we're in different vehicles. And so once this phonological route becomes automatic and we don't have to stop and think about what letter makes that sound or vice versa, I hear this sound, what letter makes it, then we are shifting into building the lexical route in the brain. And that is why I put this as a highway, because it is the fast track. So I'm just trying to show that this is where automaticity comes in. And so the last piece I'm going to talk about is the meaning section of the brain. Now, with your spoken language systems, these already exist. You hear sounds, you start to hear words, and then you start to learn what they mean, and that happens without print. But once we start to learn print, we build in this part where we see the letters, we identify the word, and we say, oh, okay, B-A-T, that's b-at. Okay, that's bat. And then once your brain says bat, oh, bat, then it travels over to the meaning section of the brain. And we know that there can be a breakdown in reading in any of these areas, right? Like we might not be able to identify certain letters, or we might not know what sounds the letters make. But the breakdown might also be that, oh, I've never heard of bat before. What is that? And then your brain is unable to make meaning because it's never heard of bat before. Maybe the student, that's where vocabulary is going to come in. You have to start to teach the student what the words mean. But let's say the student knows 3 meanings for bat. They know the animal bat, they know, the physical object, the bat for baseball, and they know the motion of batting something away. There's a bug nearby, I'm going to swat it, I'm going to bat it away. So then this is where context comes in, and we can look at the sentence and say, oh, the sentence says, Sally held the bat waiting for the pitcher to throw the ball. Well, that must be this middle one here, because that's what we use in baseball. They must be playing baseball. So this is an overview of how the reading brain works, and I hope that this was helpful for you. This is a poster that I use with teachers, and teachers are now using it to talk about the reading brain with their students. So that might be helpful for you as well. All right, thank you for all you do. Thanks for listening.